Hello guys, today we will see how to create ripples in Houdini using VEX. We will use fully VEX to create this kind of ripples. Take a geometry node and then take a grid. We will increase the size to 50 by 50, no, rows and column to 200 by 200, and this will be 20 by 20. This will be our water surface, and we will take a transform node and we will create a rain system here. So let's make this little bit up. Yeah. Now we can take a scatter node and we will scatter around 70 points here, and we will change the seed to every frame so that we will have new points generated on each portion of the grid. Now we can add a point velocity node, and we will add velocity in the downward direction. So this won't work properly since the points counts are changing on every frame. So we will add this before the scatter node. Now you can see it is working fine, and our points have also the velocities. Now we can add some curl noise to it to break the velocity force. Let's increase this little bit and keep the rest of the thing default. Take a pop network node and dive inside it. Here on the pop source, we have to choose points, no, all points. And then here, we have to emit the particle on every 10th frame or 5th frame, whichever looks better to you. So I will emit on every 10th frame. To do this, we can write this $f percentage, and this will be our frame. Now this will emit a particle on every 10th frame. So you can see this, it is looking like this. Currently the particles are going, few particles are going far away. It is happening because of there is no gravity force. Now it will look something like this. Currently the particles are going beyond the ground. To fix that, we will add a pop collision detect node. Pop collision detect, and here we will use this grid and paste it here. We have to turn off this use deforming geometry, and here we have to turn on accumulate hit, and group name we will keep hit frame. Here we will keep the response to stop or stick, whatever you prefer. Both will do the same thing. So now this will be our red points, will be our source for the ripples. How can we isolate only the red points? As you know, we have given here the group name called hit frame. This group turns 1 whenever the points get collided with the grid. So here if we take a blast node and select hit frame, now you can see the red points have been vanished. If we turn on delete non-selected, then we will only have the red points and it will look something like this. We can first delete few uh, points because this is too much. It will slow down the process. That's why we are deleting few points. Take a delete node and here go to random, then in the entity select points, and now we can delete points based on id attribute. Okay, cool. This much points are enough for the this tutorial. Now we have to calculate the age and life attribute. As you see here, we already have age and life attribute, but this won't work properly since this age is incrementing based on time, but we need to increment it based on the frame. That's why we will calculate our own age and life. To do this, first we have to delete all the attributes from here. We can simply take a attribute delete and turn on delete non-selected. This will delete all the attribute present on the point. And now we can take attribute wrangle and we will write this code. I@life is equal to chi life, and use I@age is equal to, we will keep the value 0 for now, and then we will click on this parameter icon and we will keep the life to 20. Now we have to take a solver node. Here we have to merge these two, and then we have to take a attribute wrangle. Here we can write I@age plus plus this. So now if you go on the spreadsheet and see, our age will get increment on every frame. But the problem is, if you see here, if you click on the point visualization, our point have been increasing rapidly. If you see, we have only 60 points here, but here we will have 1800 points. So this won't work. We can't inject this output directly into the ripple wrangle which we will create, so we have to sort this out. To fix this, we can take a attribute transfer. First, make sure that we are not deleting the id attribute. So in the attribute delete, we have to select id so it won't delete it. Transfer age from solver to our original particle sim. Now here we will choose age life. Now if you see in the spreadsheet, our age is increasing and we have only 1 point on each points. There are no duplicates points. Now we can take a attribute wrangle node here and we will delete the points whose age is greater than the life. To do this, we can simply write the if statement. If @age greater than @life, then we will remove the point. Remove point 0, at 80 num. Now you can see this. We have a this kind of thing. And also we can do one thing. As you see here, our points first getting down and then it's getting up. To fix this, we can add a race up, and we will connect this to our grid. And here we can choose a method as minimum distance. Now that issue will be fixed. Now let's create our ripple. So take attribute wrangle, connect our grid to attribute wrangle first input and our points to the second input. So let's write the code here, and this code will be quite big, around 30-40 lines, I guess. I will give this code in the description as well, so you don't have to write everything. So first we will declare the variables. So there will be few variables which we will declare initially. So declaration of variable is done. Now we will initialize the variable. So to initialize few variables, we will write this. Let's assume our vector pos will be at origin. Now we will calculate distance, initialize the distance, and normalize age, and age, normalize age, and then we will declare a foo variable, and then we will initialize frequency. Now we will loop through each point. So these are our points. We will loop through each points, and then we will generate ripple based on those points. So to do this, we will make a loop here for each loop. So since we have already, so we will create an variable called I, and we have already calculated the endpoints, the number of points present on one frame, and then we will write if I is smaller than n, then I will get into loop. Now here we have to do a few things. So I will increase this window. Now we have to get the position, age, and life of each point. So for the position, since we have already declared the vector pos, and we have kept the pos a value to 0, which means at origin, here we will add those get the actual value. So point, and we want position from the second input of the wrangle. So here we will write 1. We have to grab position, so P, and then point will be our I, since we are looping on the I. So our position have been grabbed, and now we have to grab distance. So here write this, and we will calculate the length from uh, current position to the point position. So we added at the rate P minus pos. So now this will be our distance. Now we have to calculate age, grab the age. So to do this, we will do the same thing. Age, comma, I. Now we have to grab the life, point 1 comma life comma I. Now we have to calculate the normalized age. So n age is equal to float age. We will make the variable to float, since our age and life are integer attributes, so we can't directly feed this into a float variable. So we will create that into a float, and here life. So our normalized age have been calculated. Now we have to fit the first we need to now we have to modify the distance based on the normalized age and the max distance. So to do this, we can write distance is equal to fit. We have to fit the distance between max distance and normalized age. So here we will write this value, and then max dist into an age comma 1 comma 0. Now we have to calculate the frequency. To do that, we can write frequency is equal to frequency pos into distance. So now we will calculate the displacement and distance using the sine function with the modulation of the frequency and amplitude. Distance is equal to sine this into frequency. Now we will write ampere here. Amplitude, sorry, not ampere. Now we will scale the distance by the normalized age. So what it will do, when the age will increase, the distance and displacement both will get reduced, so it will have a faded effect. So now what we need to do, distance is equal to into is equal to 1 minus n age. Now here we have to calculate the noise. Since if we don't add the noise, all the ripples will look extremely same. So we have to avoid that. So here we will use the Perlin noise. noise pause is equal to v direct p into, we will now use the noise scale plus noise speed into, we will animate that based on the time. Now vector noise is equal to, here we will use the noise function, and by default this noise function use the Perlin noise as far as I know. Now we will calculate the noise strength. Since here we have not declared the value, here we will set the value of noise strength. So we will calculate the length of the noise. Here we will make the foo variable to get all the values which we have calculated above. So we will use the maximum function, and this will be used for offsetting the displacement and distance. So to do this, we can use the max function. We can write foo. Our foo will be 0, since before this line we have not set any variable for this value for this. So here it will use 0, and then we will use distance. Now we can close the bracket, and here we can write v at the rate p is equal to plus is equal to at n into 2 into noise strength into, we will keep the one here. If we need the more strength, then we can increase the value, and plus, let's add the semicolon. And so here it is giving one error. Let's see what is this. Oh, we have not declared the I variable here, so let's integer I is equal to 0, age is equal to 0, and life is equal to 0. Yeah, now if we see this, our ripples should be there. Okay, we have to create the parameters for this. So let's quickly add all this. As you can see, our ripples are getting generated here. Let's increase this division size by adding a subdivide node, and let's add a normal. Now you can see the ripples are getting generated. To modify this, we can set the maximum distance to 1, frequency to around 25, and amplitude is too much right now. We can reduce to around 4.7. Now you can see our ripples have been generated, and to fix this, we can, although we can increase the subdivision here, but then also that issue will come, so we will keep it to 2 only. And after the normals, we can add delta mass, and we can reduce this step style size, and then we can add attribute blur node with the very less amount. Think the normals have been messed up, so let's add after the delta mess. Now we can increase the amplitude, I guess, from, let's keep it to 0.1. Now you can see we have created our ripples here, and it will look something like this. Let's make a flipbook and see how this looks. So as you can see here, our ripples have been generated, and this is fully procedural. If we change the point, the ripple will get automatically generated on those point position. And also we have here noise scale. So by adding the noise, you can see if I connect this normals here, and if I increase the noise scale, it will add some breakups to our uh, ripples. Let's add around 10, and you can see previously if it is set to 0, it will have the uniform circles, and if I increase the value to 10, then it will add some breakups to it, so it will look natural. And this noise are it won't look like static noise. So thank you guys for watching. If you like this tutorial and found this channel helpful, make sure to hit the like and subscribe button, and also you can support me on Patreon.